Hi, welcome back to Unit 7, Day 3. We are still working with proving that we really do have a parallelogram when given a quadrilateral. And we said we have 5 theorems that are going to help us prove that. The first one, both pairs of opposite sides are parallel. The second one, both pairs of opposite sides are congruent. The third one, both pairs of opposite angles are congruent. The fourth one, both diagonals bisect each other. And the last one pair of opposite sides is congruent and parallel. Okay, so let's continue looking at some examples. Number 9, 10, and 11, we want to know what values of x and y would enable us to prove that the quadrilateral is a parallelogram. Okay, so basically, if this is a parallelogram, okay, what would I need x and y to be to make this indeed a parallelogram? Well, I have information about all of the side lengths. So when I look up here, information about the side lengths, let's see, we've got sides are parallel, so that's not really the lengths. Here I've got opposite sides are congruent. Number 2 is going to help us with this one. I need both pairs of my opposite sides to have the same measure, right? So that's what we're going to do for number 9. I want both pairs of opposite sides to have the same measure. So that means my top and my bottom have to be equal to each other. My 2x minus 2 has to be equal to the opposite side 12. Okay, so when I solve that, I'm going to add 2 to both sides. Which is going to give me 2x equals 14. Divide both sides by 2. And x is going to equal 7. Okay, for the second problem, I need the left and the right opposite sides to be congruent to each other. So I need 2y to be equal to 8. That one's a little bit quicker. All I have to do on this one is just divide by 2, and y equals 4. So on this problem, number 9, what values of x and y would enable me to prove that this quadrilateral is a parallelogram? We can say if x equals 7 and y equals 4, then it is a parallelogram. Okay? All right, number 10. On number 10, what values of x and y would enable us to prove the quadrilateral is a parallelogram? Okay? So notice back here, I didn't have anything about angles except number 3, both pairs of opposite angles are congruent. So I do have to show both pairs of opposite angles are congruent. So I need to show that this pair of opposite angles is congruent, and I need to show that this pair of opposite angles is congruent. Okay? Well, this one's going to be pretty simple because 11x needs to equal 55. Okay? So on this one, I'm just going to simply divide by 11, and x is going to equal 5. If x equals 5, then these two angles will be equal to each other, that are across from each other. I also need these two angles to equal each other, but I don't know what this one is over here. It might be tempting to do put a 5y there and say 5y equals 5y. But if I try to solve that, 5y equals 5y, I'd need to get all my y's on the same side, and then I would get stuck because I would have 0 equals 0, and I wouldn't know what to do with that, right? I'd no longer have a y. So that's not going to work for me. But I don't know it's a parallelogram, so I can't use parallelogram properties yet until I show that it is indeed a parallelogram. Okay? But I do know that in a quadrilateral, all my angles have to equal 360, right? And I know this one's 55, and I know this one's 55. I know the sum of all the interior angles is 360. And we can do that with that n minus 2 times 180 and put a 4 in. 4 minus 2 is 2. 2 times 180 is 360. I know I've used 55 here and 55 here. So I've used 55 and 55. So that's 110 out of my 360. Okay, so then that's going to give me 250 left over. And that needs to be equally divided into these two angles. So I'm going to divide that in half. So each of those angles have to be 125. This one has to be 125, and this one needs to be 125. Okay, so these angles have to each be 125. So 5y needs to equal 125. Okay, I'm going to divide both sides by 5. And y needs to equal 125 divided by 5 is 25. So on this problem, I know that lime green is a little difficult to see, but on this one, if x equals 5 and y equals 25, then it is a parallelogram. Okay? All right, one more. Okay, on this one, I have information about half those diagonals, which remember we did in the last video. We used those little pieces of the diagonals to be able to show parallel, alternate interior angles. Then I had parallel sides. Okay, so I'm going to be able to use this angle and this angle. If they equal each other, then I can say these two sides that they touch, so the left and the right, not the top and the bottom, because they don't touch the top and the bottom, right? It touches the right side, it touches the left side. I can say the left and the right are parallel. So if 9x equals 45, then my left and my right sides are parallel. So I'm going to divide both sides by 9. And 1x is going to equal 5. If x equals 5, then this is going to be parallel to this. I don't have information about these other angles to do my top and the bottom, to show the top and the bottom are parallel. I don't have any information about the top or the bottom. So I can't use this number 1, both pairs of opposite sides are congruent, or sorry, parallel. Where else do I have parallel? Down here. One pair is both congruent and parallel. Well, I've already showed parallel. Can I also show that the measure of the left side is equal to the measure of the right side? If this 6y is equal to that 18, then I will have one pair of opposite sides both being congruent and parallel. So all I have to do is divide both sides by 6. If y equals 3 and x equals 5, I'm going to have a parallelogram. So on this one, if x equals 5 and y equals 3, then it is a parallelogram. Okay? All right, in the next video, we're going to look at this last figure and see how do we do this on the graph? How can I determine if ABCD is a parallelogram when I graph the 4 corners? And we're going to talk about the different methods to do that and what you might think is the easiest method, because what I might think is easy might not be what you think is easy. So we'll talk about a couple different methods to be able to do that. All right, so come on back to the next video so we can discuss how to work with parallelograms or quadrilaterals on the coordinate plane. All right, thank you so much for watching.